As part of the previous lecture, we have gone through details with respect to inner join between multiple tables. Now it is time for us to explore outer joins. When it comes to outer joins, there are two types of outer joins. One is left or right outer join. Second one is full outer join. When it comes to left or right, both mean same. It all depends upon the side of the table. We use either left or right. When it comes to full outer join, it is nothing but table 1, left outer join table 2, union table 1, right outer join table 2. First, let's understand what is outer join, then we'll take it further. When it comes to inner join like this, when we run the query, we'll get the results based upon the join condition. Whatever data satisfies the join condition, we'll get the result based on only that join condition. If you look at the count is nothing but 172,198. The reason why we are getting 172,198 as count is because order underscore items have those many records. There are no violations when it comes to foreign key constraint between order items, order item, order ID and orders, order ID, and hence we are getting the count as per the count in order items. Now, if we review the data model diagram, there is a possibility that there might be orders for which there are no order items. When it comes to relationship between orders and order items, even though it says one to many, there could be some orders where there are no corresponding order items. We might want to see those details from orders as well, where the join condition doesn't satisfy. That is where outer join comes into picture. Before getting into the outer join, let's make sure we analyze data related to order IDs in orders and order items. Then we'll take it further. First, let me get the count of distinct order IDs from orders. For that, I should be able to come up with a query like this. Select count of distinct order underscore ID from orders. Now, let me select this and let me click on this to run. You can see the count, it is nothing but 68,883. In the similar manner, I would like to get the count of distinct order item order IDs from order underscore items. Let me paste the query here. Let me change this to order underscore item underscore order underscore ID. When it comes to the table name should be order underscore items. Now let me select this and let me run it. The count is nothing but 57,431. So when it comes to order items, we have only 57,431 order IDs, whereas in orders we have 68,883 order IDs. We might want to get these additional orders as well, along with those orders which satisfy the join condition. That's where the outer joins comes into picture. Now let's make sure we pick this query. Here I am not making any significant changes. I am just saying left outer join in place of join. When we run this query with just join, it have returned 172,198 records. You can see 172,198 records here. When you run this query with left outer join between orders order ID and order items order item order ID, the number will be higher. You see, it have returned 183,650. The difference between 183,650 and 172,198 will be same as the difference between these counts. If you want, you can actually make a note of these counts and compute the difference. Also, you should be able to compute the difference between the counts of the join queries, inner as well as outer joins, and then the difference will match. So when it comes to outer join, on top of those records where the join condition satisfies, we'll also get those records where we have data in the driving table. In this case, orders is driving table, but not in order items. When it comes to order item product ID and order item subtotal, which are from order items, in case if we get those order IDs which are there in orders but not in order items, these two values will become null in this query. Now let me actually add one more field here. It is nothing but order underscore ID. Then let me actually make sure line break here. As part of order by, let me specify order ID so that we can review the data easily. To specify order ID in order by, we can actually use 1 because the first column in a select clause is nothing but order ID. Now let's select this and let's click on this to run. You can see the output here. For order ID, we have one record. This is the order item product ID. This is order item subtotal. Let me also add one more field here. It is nothing but order item ID, which is primary key in order items. Now let me run this. So when it comes to the first record, Order ID and order date are coming from orders. Order item ID, product ID, and subtotal are coming from order items. When it comes to order ID 2, we have 3 records. You can see the 3 records here. If you observe, order ID and order date are repeated because we have only one record in orders. These two are coming from orders, and hence for all the 3 records in order items, these are repeated. However, when it comes to order items, order item ID, order item product ID, order item subtotal are related to 3 different records. You can see those 3 different records here. Now when it comes to order ID 3, there is no corresponding record in order items. Hence, we are only seeing the information from orders. When it comes to order items fields, there are nulls here. This is how the outer join results will be. The count will be the inner join result plus the additional records which are there in a driving table. When it comes to the values related to the child table or the other table on which we are performing outer join, if there are no corresponding keys in that table, then the values for the columns related to that table will be nulls. You can see 3 as an example here. When it comes to 3, there is no entry in order items, and hence all the values related to order items are null here. This is how we perform outer join between 2 tables. If the driving table is on the left side, we use left outer join. If the driving table is on the right side, we use right outer join. That's why whether it is left outer join or right outer join, both mean same. Sometimes if we have 2 tables, there might be some records which are there in first table but not in second table, and also vice versa, which means there might be some records which are in second table but not in first table. If you want to get all those records which satisfy join condition plus those records which are there only in first table and also those records which are there only in a second table, then we use full outer join. When it comes to definition of full outer join, it is nothing but table 1 left outer join table 2 union table 1 right outer join table 2. This is how you can get started with joins. As we have gone through both inner joins as well as outer joins, now it is time for us to explore how to process the join results further. I'll be covering those details as part of subsequent lectures.